Okay, in this video we are going to start talking about fractions. So I am looking at page 125. So if we read the top of page 125, it says, "You're in charge of the Student Education Association cake sale. As you leave to buy some paper plates, you ask someone you don't know to cut all of your cakes. When you return and look at the cakes, here's the picture of the cakes. You gasp. The plan has been to charge $5 for a whole cake, and you have thought that each piece should be priced by dividing $5 by the number of pieces if necessary." So first of all, for each cake, is it fair to charge the same amount for each piece? So one of the most important things to think about fractions is we need equal size pieces. So that is what this activity is trying to do. So is 8 divided into equal size pieces? Would it be fair to charge the same amount for each of those pieces of cake? So yes. What about B? Would B be fair to charge the same price for each piece? So you might be tempted to say no. However, if you make some additional cuts, let me do it with a highlighter. If we cut the top 2 pieces in half and then cut the bottom 2 pieces in half, you should see that each original piece is made up of 2 rectangles. So even though they don't look the same, they are the same size pieces. What about C? This would be no, so you should be able to tell that the top or the edge pieces are smaller than the inside pieces, so that would be a no. D, are these cut into equal size pieces? So again, if we cut this, additionally, you should see each original slice is made up of 2 of the same size triangles, so this one is yes. E, are those pieces the same size? So yes. For F, because this is a rectangle, these 2 pieces are larger than those 2, so that would be no. For G, no, so those 2 pieces are the same but not the top one. For H, you should clearly be able to tell this top piece is not the same size as the others, so that one's a no. For I, so again, it's been cut into 3 sections, and then each section has been cut in half. So if we make our additional cuts, we can see we have same size pieces. So this one is a yes. For J, the top half is fine, but the bottom half is not. These are clearly smaller than these, so that would be a no. And then K, we have same size pieces, so that's yes. And L, those are same size pieces. So cakes A, B, D, E, I, K, and L would all represent equivalent pieces, and you could charge by the slice for those. So we're going to skip the questions at the bottom. All right, so next, same idea, we're going to jump to page 129, which is called Fraction Action. So it says, each of these drawings represents a whole. Determine if each fractional part is correctly modeled. If not, model it correctly. So here's a picture of a hexagon that has been split into thirds. So are these appropriately split into thirds? Are those all the same size pieces? So yes, so this one is fine. What about number 2? Is this circle been appropriately split into 3 equal parts? So no. So what is the appropriate way to split into 3 equal parts? So it would be almost like the peace sign. So something like that. Okay, what about number 3? Has this been appropriately split into fourths? Are those the same size pieces? So yes, because, oh, so sorry, this one was a no. So yes, this one should be fine, because what did they do? They chopped it in half, and then they took this half, cut it in half, and then they took this half and just cut it in half in a different way. So those are all still fourths, even though they don't look the same. For number 4, is this the appropriate way to cut the star perfectly in half? No. So it should be a vertical line through the middle. We'll be splitting it in half. Down here to number 5. Sorry, this is a no. So number 5, has this parallelogram been split perfectly in half? Yes. And the last one, number 6, is this 3 equal pieces of this trapezoid? So no. So the best way to split this into 3 equal pieces would be make 3 triangles. So this is how you would split it into thirds. Okay. So the big idea, again, first when you're working with little kids is just, can they identify equal sized pieces and say equal sized pieces. Again, not necessarily the same shape, but equal in size. Okay. All right. So now we're skipping that page. So we're going to jump ahead again to now look at page 132. There are 3 different ways that we can model fractions. So we have length models, area models, and set models. So everything that we have already looked at before are area models. So talking about cakes and the shapes that we just look like, we were looking at the size of them. Okay, so we have 3 different ways. So the length model, so thinking about a particular length, that is normally done on a number line. So first of all, it says to model the fraction that is 3/4. It's kind of hard to see, but if you were thinking about putting 3/4 on a number line, we would have to designate where 0 and 1 is. And then 3/4 would tell us that our whole is split into 4 equal parts. So if we split our number line into 4 equal sections, 1, 2, 3, 4, then we have 3 of those pieces or 3 of those sections. So 1, 2, 3. So 3/4 will be right there. So let's put an X where it is. Now for area, I like to draw rectangles. So an area model, again, you have an area of some shape. It is split into 4 equal size pieces. And then you have 3 of those pieces. So that would demonstrate 3/4. And then a set model would be if you have individual units of something. So like cookies, marbles, cupcakes, pumpkins. So like individual items. So a set model would look like you would have 4 objects, whatever they happen to be. And then you have 3 of the 4 objects. Okay. All right, so what about 5/8 in our 3 different models? So 5/8, again, we need a number line going from 0 to 1. It would need split into 8 equal parts. So there's 4, so cut each one in half. So there's 8 equal parts, and then the 5th one, so 1, 2, 3, 4, 5. So 5/8 would be right here. For an area model, we need some sort of area or shape split into 8 equal parts. And we have 5 of them. And then for a set model, you need 8 individual items. And then again, we're taking 5 of them. Okay. All right, so then what about mixed numbers? 5/3. So 5/3 is bigger than the whole. So this time we're going to make a number line from 0, 1, and 2. So again, if we are just thinking about parts compared to wholes, it takes 3 to make a whole. So our first unit is split into 3 equal parts. Our second unit would be split into 3 equal parts. And then we have 5 of those parts. So 1, 2, 3, 4, 5. So 5/3 would be right there. So do not convert that into 1 2/3. Just leave it as 5/3. In terms of an area model, again, the whole is going to have 3 equal parts. So maybe we have one cake split into 3 equal parts and a second cake split into 3 equal parts. So we have 5 of those pieces. All right, and then a set model. So it takes 3 in a set. Okay. So this one's a little tricky because if we do what we've normally been doing, it kind of looks like we have 6 things. So if I just color in 5 of them, you may be tempted to say this fraction is 5/6. So somehow we need to designate that there are 3 parts to the whole. So I'm just going to draw a box around these. Okay. So maybe you have 3 cupcakes in a box or 3 cookies in a box. So you'd have 1 full box and then 2/3 of another box. Okay. All right, so now let's apply these problems in some new situations. Okay, so again, we have length, area, and set models. All right, so number 4 says, show a length model for 2 1/5 if this is 1 unit. So if this line right here represents the number 1, how would we draw a picture of what 2 1/5 looks like? So we would need 2 of these. So, and I do want you to draw this independently. Don't draw attached onto what was already given to you. But if you can kind of estimate. So like, okay, so maybe that's 1 unit. Here's how long a second unit would be. So 2 of those lines together. So think of it this way. And then a 5th. So in order to figure out how big a 5th would be, we would need to split this into, here comes my cat. You might see him. 1, 2, 3, 4, 5. So 5 parts, 1, 2, 3, 4, 5. So a 5th would be 1 of those little sections. So it's going to be about like this much more. So 2 1/5, I'm going to just highlight it, should be about this long. Okay. In the next one, show 7 halves on an area model if this is 1 unit. Okay, so if this is 1, in order to make 7 halves, we know that the whole has to be split into 2 parts. So how could we split this into 2 equal parts? So if we chop it right down the middle vertically, and then we have 7 of these parts. So there's 2 of them, 3 of them, or sorry, 4 of them. So 1, 2, 3, 4. And then we have 5, 6, and then you'd have a 7th one. So this would be equal to 7 halves. Or if you convert, that would be 3 1/2 triangles. You simplified it. But I do, when you're drawing your pictures, need to see where the 7 halves is coming from. So I expect to see the 7 identical pieces you have compared to the 2 it takes to make a whole. All right, and then in number 6, it says show 4/3 if this is the whole. So if that is considered 1, first of all, we want to split the whole into thirds, 3 equal groups. So how could I split this into 3 equal parts? So there would be 2 triangles per group. So then I would have 4 of those groupings. So I'm going to have, so there's my first group, my second group, my third group, and my 4th group. So this would be a picture of 4/3. Okay. All right, on to the next page. Let's see, page 133. Okay. All right, so now we're doing something in reverse. So on that last page, we were told, let me get it back out again. So on the previous page, we had a picture of what 1 looked like, a picture of what 1 looked like, a picture of what 1 looked like. So this time, now we're doing the opposite. So now we have a picture that shows a fraction and we want to draw the whole. So we want to see what 1 looks like. Okay, so if this is currently a picture of 1/5, what would a picture of 1 look like? So we currently have 1 piece that we need, and it takes 5 of those pieces to make the whole. So we would just need 5 of these. Okay, so that's going to be like 1. Same thing in the next one. If this is a picture of 1/6, this would be 1 piece that you have, and you would need 6 of them to make the whole. So 2, 3, 4, 5, 6. So that would be the whole, or you could draw 3 full circles, whatever you choose to do. For number 9, this is a picture of that says 3/4. I know it's kind of hard to read. So if this is 3/4, that tells you that you currently have 3 equal sized pieces. So start with that, chop this into thirds. And then it would take 4 of those pieces to make the whole. So 1 should look like 4 of those pieces. Okay, so 1's going to look like that, be that long. That's a length model. In number 10, again, I think this says 3/4. So if this is a set model, so if this represents 3/4, then first of all, we have 3 equal sized parts or 3 equal sized groups. So what would those look like? So 1, 2, 3. And then it would take 4 of those groups in order to make the whole. So let me draw the whole over here where I have some more room. So how many hearts would that be? So there's 1. Now I'm terrible at drawing hearts. So 2, 3. So it should be a total of 16 hearts would be in the whole. Okay, so a whole would be 4 of those groups. All right, then 11 and 12 show improper fractions. So with 11, 7/4. So that means we know we currently have 7 pieces. So let's try this. So 1, 2, 3, 4, 5, 6, 7 equal sized pieces. But it only takes 4 of them to make the whole. So the whole, I'll try and make it the same size. So the whole should look something like that. And then finally, number 12, if this is a picture of 6/5, so you have 6 equal sized pieces right now. So if this is like a pizza, let's try and chop this into 6 equal pieces. So that's 6/5. So the whole would just be 5 of those pieces. So it's going to look kind of like a Pac-Man. So kind of like that. I should have drawn this up a little bit. But this would be the whole. Okay. So let's see. So we have area model, length model, set model, area model, area model. All right, and then our number lines are here at the bottom. So 13 says mark 3/5 as a point A and then 5/3 as point B and show how you make that representation. Okay, so to start with the easy one, 3/5, that means you want to split the whole into 5 equal parts. So between 0 and 1, that whole would be 5 equal parts. So 1, 2, 3, 4, 5. So 3/5 would be the third one. So 1, 2, 3. So there's A, which is 3/5. And then for 5/3, I'm going to have to use my marker because now we should be splitting the whole into 3 equal parts. So from 0 to 1, now let's do 3 equal parts. So that should look something like 1, 2, 3. And then we need some additional since we have 5 of them. So 1, 2, 3. So 5/3 should be at the fifth one. So 1, 2, 3, 4, 5. So B should be about here. So it's the fifth section after the whole has been broken into 3 parts. Okay, 13. All right, 2 more. All right, so now 14. It says, show how you would accurately represent the points 3/4, 1, and 4/3. So this one's a little different because we're just given 1/8 and 1/2. So in order to do this, you would need to know those benchmark numbers of where 0 and 1 are going to be. So what do we know? So 1/8 and 1/2. What is 1/2 equivalent to in terms of eighths? So 1/2 would be the same as 4/8. So if this is 1/8 and this is 4/8, you should be able to figure out where 2/8 and 3/8 would belong. So this would be about 2/8. This would be about 3/8. So then using that same method, if we go backwards, that means 0 should be about right there. And then if we move forward about the same distance, here would be 5/8. This would be 6/8, 7/8, and then 8/8, which would be 1. So now, 1 we've already found, it's right there. So check that one off. 3/4. What is 3/4 equivalent to? 3/4 is equivalent to 6/8. So 3/4 would be right here. So we can check that one off. Okay. And then what about 4/3? So we know where 0 is, and we know where 1 is. So in order to make 4/3, we would have to split this into 3 equal size pieces. So let's try that. So maybe that's about right there if we estimate. So then if we take about that same distance in the opposite direction, we would have, so 1/3, 2/3, 3/3, which is 1. So then 4/3 should be right here at the end of our arrow. Okay, so that's where 4/3 is located. All right, and then same thing with 15. 15, we want to find 0 and 2/3, and I already know this is one where we have to extend the line because it's not long enough. So what do we know? 3/4, 1 and 1/4 is equivalent to 5/4. So if we know where 3/4 and 5/4 are, then right in the middle should be 4/4, which is 1. Okay, and then using that same distance, we should be able to work our way back to 0. So if that's about 1/4, going back that same distance, so this should be about 2/4, which is 1/2. That same distance would be another 1/4, so there's a 1/4. And then that same distance right here on the edge of the paper, there's 0. So we can check that off. And then again, to find 2/3, we want to find, here's 0 and 1, there's our unit. It would need to be split into 3 equal parts. So that's about like that. So 2/3 would be 1 2/3. So 2/3 is a little bit more than 1/2, and it's a little bit less than 3/4. Okay. All right, so we are not going to do the rest of page 134. Okay, so this is all I wanted to introduce you to today in this video regarding the 3 different types of ways that we represent fractions. Okay, so for homework, I want you to try. So it's page 147. There's some puzzles about fractions. You are also going to try page 148. Some more puzzles about fractions. you are going to try page 149. So this should look familiar. We did some examples of this in our video earlier. So 149. I want you to try page 150. So 150. And then our number lines, if you jump ahead in your course pack, number line problems are on page 162 and 163. Okay, so that is, 6 pages of things that I want you to try. However, I am not going to make you actually submit any of these pages. So what I want you to do is this week to try these pages out, and then next week I will make a video that goes over all of the answers to these fraction pages. Okay, so you can see what is happening. Okay, so no submitting of the homework, but try these out. You do have a test coming up in 2 weeks, so not next week during part of fall break week, but the week after is your next exam. So hopefully this will help you prepare for those. So thanks for watching.